Welcome back, everyone. We are back for our biology, advanced level biology, and earlier on we had looked at disaccharides as carbohydrates, the second chemical of life. So far we are discussing that said among disaccharides, the three most common disaccharides are sucrose, maltose, and lactose. That said, sucrose is commonly called the cane sugar, the one that is harvested from sugarcane. Maltose, commonly found in malt. It's called malt sugar on market. Then lactose is commonly called the milk sugar, the one traded as lactose milk, as needle, it is milky sugar. We had also said earlier that maltose and the lactose are reducing sugars. So the test for reducing sugars using Benedict solution can find them in foodstuffs, but sucrose is non-reducing. Meaning when you boil it with Benedict solution, you don't get a positive test. Positive test, I mean the color changes as we looked at them won't happen. So if it is non-reducing, how do we test for its presence in a foodstuff? And then look at the test for non-reducing sugars. Test for non-reducing sugars in food substances. So our procedure, if I'm to make another table, the format how it looks like in number 2. The table would be in the formats we looked at earlier. With the procedure, the test procedure, the observation, and then the conclusion. In our procedure, meaning what we're going to follow, we get to 1 cubic centimeter of the food substance meaning we deal with solutions since they are soluble in water. We add 2 cubic centimeters of dilute hydrochloric acid and we boil. Then we allow to cool. Allowing to cool will mean that you give it some time to cool. We don't dip it in water because we are dealing with glass apparatus. It will just break apart. Allow to cool. Then add 2 cubic centimeters of sodium hydroxide followed by 2 cubic centimeters of Benedictine solution. And boil again. We're going to find this as our longest procedure of all the food tests. So let's first digest this procedure here. Why we add in dilute hydrochloric acid to the disaccharide, to our sucrose solution? So dilute hydrochloric acid hydrolyzes let's say sucrose now to its constituents, that means to glucose and fructose. That's why we are adding dilute hydrochloric acid. Then, why do we add in sodium hydroxide after cooling? The worker for sodium hydroxide also it will be dilute sodium hydroxide, is to neutralize excess HCl. Then we go ahead, add in Benedictine solution to the mixture. Now the Benedictine solution added is now testing for the reducing sugars now being formed by hydrochloric acid. So if non-reducing sugars are present, we don't test for them directly. We are testing if we hydrolyze them, if we break them down into their constituent monosaccharides, which are reducing sugars, then we can test for the presence of the reducing sugars being formed. So meaning our observation side is going to remain. We are going to have that the colors change from blue, that is for Benedict, to green, to yellow, to orange. So meaning we shall have created reducing sugars which can now be tested using Benedict's solution. Of course, we shall conclude and say non-reducing sugars present. Non-reducing sugars present. So that is our test for non-reducing sugars. So if you get a food substance that you think or has been labeled that it contains sugars, we can now able test for them and say, let me see how much of the reducing sugars are present, how much of the non-reducing sugars are present, if any. So we expect that the food substances, sodas, beers can be quantified now, and we say, let's see if they contain any sugars. So in our next session, we shall go now to the next group, which are the polysaccharides.